Friend, welcome back. This is Golden Sun. In this video, we'll try the famous bubble sort. Um, it's not very efficient sorting, but it's easier to implement and easier to understand. Okay, let's get started. Um, let's let's try to create an array of random integers. Okay, um, array or numbers equals array of integers. This is a generic type, and for we don't need that. And a range 0 dot dot dot, let's do 7 in random integers. Okay, append, this one will be ARC random is there ARC, this one, so we can provide an upper bound like that, and the autofix will add the casting to int. Okay, so we can print out this original array. Okay, like numbers. Run it. Next, we'll try to bubble sort this array, right? 7 of them. Bubble sort. Let's introduce the idea, the algorithm of bubble sort. Say we have 4 numbers here, right? Bubble sort, the strategy is we'll sort adjacent pair of numbers, and for example, going from the left to the right? So for example, this one we compare with its neighbor, this guy, and we'll push the bigger number to the end. Okay, so for example, 3 will move our index or cursor starting from the first 3 compared with the next one. 7 is already in order, right? 7 is greater than. Okay, now let's move our pointer or cursor here. So 7 compared with 2, 7 is greater than 2, so we'll swap them like that. Okay, so now our cursor moved to the 3rd place, right? The index is here. 7 compared with this one. Okay, 7 is greater than 5, so we swap this pair. So when we finish this pass, right, the largest number will be pushed to the end of this row. Okay, now we only need to handle the first 3 elements in the array, right? We're starting from this first one again. 3 is greater than 2. Okay, we need to swap that. Now 3 is less than 5, so there's nothing we can do. We need to do, right? It's already in good order. Okay, so this is the second pass. We make sure the second largest is in place, right? We don't need to touch that one. It's already done in the first pass. Now let's continue. In the next pass, we'll start from the beginning, and we only need to handle, right, the remaining 2 elements. So 2 is already less than 3. We don't need to swap it. Okay, so it's done. This is the sorted result. Okay, so we'll migrate this strategy into our code. Okay, so we need a for loop. So this end will be the end of our each pass. Okay, so this end will start from the 1 less than, okay, let's put a range here, 1 dot dot less than a number dot count, reversed, right? So the first one, for example, we have 7 numbers here, right? So we'll start from the end, we'll start from this one, right? This is index 0, index 1, right? This is all the end index pointing to, okay? So the first end will point to this location, okay, this index. So now we can create a variable like swapped equals false. So if in the current path, if there's nothing swapped, it means we are done, right? So that's a flag here. I in 0 less than n, right? So in the first round, we'll start from this one to here. We'll compare. So if our numbers sub I is greater than number sub I plus 1, right? If this one is greater, then we'll do swap, right? Swap at, so I and I plus 1. Then we can make update the flag. So at the end of this, the current pass, we check, right? If not swapped, right? If not swapped, it means there's nothing we need to do. We can break. So after that, we can print our sorted number, sorted version of that array. Sorted. Let's run it. Sorted. 21 is, oh, we have 221. Yeah, 221. 40, that 45, yes, it's here. And 98, is it the biggest? Yes, the largest, right? Cool. That's it. Thank you for watching. See you next time.